we live in a world that is just absolutely drowning in data. It's everywhere. It shapes our social media feeds, the shows we binge watch, pretty much everything. But with this total flood of information, how does anyone find any real, meaningful answers? Well, let's break it down.
Get ready for this number. 2.5 quintillion. That's quintillion with a Q. That's the mind-boggling amount of data we create every single day. Your smartwatch, your car, even your coffee machine, they're all contributing to this data explosion that's just getting bigger and bigger. So how on earth could you possibly process all of it?
And that really brings us to the big question, right? How can anyone make sense of this much data? I mean, trying to analyze all of it isn't just a bad option, it's basically impossible. It would be way too slow, way too expensive, and honestly, it'd be a total dead end.
So the solution here isn't about working harder, it's about working smarter. We need a shortcut, a really intelligent way to get insights without having to look at every single piece of information. And that shortcut? It's called sampling. It's the art of picking a smaller, manageable piece of data to understand the entire picture.
Okay, so to really get a handle on sampling, there are two key terms we've got to know. They're pretty much the bedrock of statistics: population and sample. Think of it like this. It's the difference between watching an entire movie series and just seeing a single perfectly chosen snapshot that tells you the whole story.
All right, first up is the population. Now, this isn't just about people. In statistics, the population is the entire group we're interested in. It could be all the voters in a country, every single movie available on Netflix, or all the cars made by a certain factory. It's the whole shebang, the entire universe of data we want to understand.
And then, from that huge population, we take what's called a sample. It's a specific, smaller group that we actually collect data from. The whole goal is for this small snapshot to be a perfect little miniature of the whole thing. That way, we can draw some pretty accurate conclusions about the entire population without all the heavy lifting.
But, and this is the really crucial part, not all samples are created equal. If you want that snapshot to be accurate, you can't just go picking and choosing whatever's easiest. Nope. You need a fair, scientific method. And that brings us to what's really the gold standard: probability sampling.
So what is it? Well, probability sampling is a method where every single member of the population has a known, and this is important, non-zero chance of being selected. This is the magic ingredient, the key principle that makes a sample fair and truly representative. It's how you eliminate bias and make sure the conclusions you draw are solid.
Okay, so how do data scientists and statisticians actually pull this off? Well, there are a bunch of techniques, but we're going to focus on three of the most common and, frankly, most powerful methods used to create a fair, probability-based sample.
First up, you've got simple random sampling. I mean, this is the purest form you can get. It means every single member of the population has the exact same equal chance of being chosen. It's literally the statistical version of putting everyone's name into a giant hat and drawing them out completely at random. No rhyme or reason, just pure chance.
All right, next we have systematic sampling. This one's a little more structured. With this method, you select items at a regular interval. So, for example, you might decide to pick every 10th person who walks into a shop, or you might pull every 100th record from a massive database. It's still random, but it's got a system to it. And finally, there's stratified sampling. Now this one is super useful, especially when your population has some really distinct subgroups, or strata. What you do is first divide the population into these meaningful groups, say different age brackets or people from different cities, and then you do a random sample inside each of those groups. This technique guarantees that you get a voice from all the important segments of your population. Okay, so let's do a quick recap. Simple random is pure chance, just like drawing names from a hat. Systematic is structured randomness, like picking every 10th person in a line. And stratified makes sure all the important subgroups are included, like when pollsters make sure to talk to voters from different age groups. Each one is a different tool for getting to the same goal, a fair, unbiased sample.
I know this might all sound a little academic, right? A bit like a statistics class. But the truth is, these sampling techniques are quietly shaping the world around us every single day. They are the engine behind some of the biggest business decisions and the products we all use and love.
I mean, just think about it. When Netflix suggests a new show for you, they aren't analyzing what every single person on the planet is watching. They're analyzing a sample of viewing patterns to predict what you'll probably like. Or take Walmart. They famously use sampling to find out that right before a hurricane, sales of strawberry Pop-Tarts went up by like 7 times. That crazy insight helped them stock their shelves better. That's sampling in action. When you boil it all down, it really comes to this. Data science is all about surfacing the hidden insights that can help companies to make smart business decisions. Probability sampling isn't just a math exercise. It's the tool that lets us find those hidden gems in a giant sea of data and turn them into real, actionable ideas.
So really, from the political polls you see on the news, to the stuff on your grocery store shelves, to the very next show that pops up in your streaming queue, our world is being shaped by what we learn from these tiny samples. So the next time you see a new trend or a surprising headline, just ask yourself, what little snapshot of the world led to this decision?